In this tutorial, I'll show you how to make a vertical wall run. Our character collides with the wall and starts running up. The higher it goes, the slower it climbs until the wall run ends. And as an added bonus, I'll show you how to incorporate the ledge grab from a few tutorials ago, so check the description if you haven't seen that already. It's pretty simple, so let's just get into it. Here we have a new third-person template. I've just taken a wall and put it in front of our player start. The idea is that when we run towards the wall, we want to hold down a button, say Shift, and when it impacts with the wall, our character starts moving upwards. So we can open up our third-person character, and we could start this with a keyboard press. We're going to bind it to Shift. Now, when we press Shift, we're going to start a timer. And when we release Shift, we're going to clear and invalidate the timer. We can make a custom event. And we'll just call this wall trace. Promote this to a variable off of our timer. We'll call it wall trace timer. Off of our released, we're going to clear and invalidate timer by handle. And we only want to be doing this if we're not already running on the wall. So we're going to make a variable at the start and we're going to call it running on wall. We're going to get a branch. So then if we're not currently running, we start our event. Off of our wall trace, we're going to get a line trace by channel. Our start is going to be our actor's location. And our end is going to be a distance in front of us. We're going to get our forward vector. We're going to multiply this. Convert it to a float or an integer, we'll say just 50 units. And then we're going to add these two together. And then for our timer, we want to have this looping every 0.01 seconds. Okay, so when we hold down, we're tracing, and when we're not holding down Shift and we release it, we're no longer doing that. If this trace hits, we get a branch and we'll break the out hit. Regardless of how we impact the wall, we want to turn our character to face the wall directly. So we can get the wall normal and multiply it by -1. Then we want to make a rotation from X. And we want to set this to be the actor's rotation. Now, because the player has control over the movement, we may want to disable input because any movement's going to just mess with the rotation. So before we actually change the actor's rotation, when we confirm that we hit, we're going to get the player's controller. And then we're going to disable input. And switch this target to the player controller. Then we're going to want to set the movement mode to flying. So we drag off our character's movement component, set movement mode to flying. And then we're going to add a movement input. But because our character is disabled, or our character's movement is disabled, we need to be able to repeatedly send this movement input for the duration of our run. So we're going to make another timer. We could just copy the one that we have up here. We're going to make a custom event, and we're going to just call this move. We can keep the same looping and the 0.01 for our time. We're going to promote the handle for the timer to a variable, and we're just going to call it move timer. And then we're going to get a delay. And this delay, after it's finished, is going to clear and invalidate the timer. We're going to have to do a few more things before we get to this, but we're just going to run through the movement first, and then we'll worry about setting all the variables. Now, when we add our movement input, we obviously want to be moving up on our world's direction. So we need to get our actor's up vector. And before we call this move, at any time here, we actually need to end this wall trace timer. So we will clear and invalidate timer by handle again. And just copy our wall trace timer tag here. Now if we test this out, our character is moving upwards. So after we clear and invalidate the timer, we're going to copy our player controller, and we are going to enable input. I'm just going to change this to 0.5. So we're able to move around, and then we want to get our character movement component, and we want to set our movement mode back to falling. And I'm going to drag in our movement timer and place it here, and I'm going to cut this and add it to its own event. We'll get a custom event, and we'll call this stop wall run. And we have a little bit of a drift here, so what we're going to want to do is before we change our movement mode to flying, we want to stop our movement immediately. Now, at any point after we stop this clear and invalidate timer handle, we need to set our running on wall to be true. So we're going to detach this ribbon here, and under event, we're going to say create event. And from the drop down, we'll select wall trace. That way we can just detach this. We're going to move that clear and invalidate timer after we hit our branch as being true. Truly does not matter since it's just going to run through this once either way, but I like to just end this after we confirm we have a trace. And we'll set this right after we disable the input. Of course, because we set it there, once we are off the wall, we need to uncheck running on the wall. Now, I had made an animation for this comprised of a Mixamo animation, a couple blended bones, and layered blends. It's not entirely important, but we have it running off of this running on wall variable. The only thing I want to say is in your animation graph, if you are doing a animation where your character is running straight up and you base it on ground speed, you need to change the vector length XY that's default in the program to just use the vector length. That way it will pay attention to the Z value. And now if we run it, we do get kind of an awkward animation because our character is facing straight up. This can easily be changed by adding yet another node here, and we can get this even after the set actor rotation, is that we want to set a relative offset. We can take our character's mesh, add relative rotation. And we're going to put it back 20 degrees. And then when we are off the wall, what we need to do is just add 20 degrees. So now our animation kind of looks like our character running up the wall a little bit. Except because we're also using the feet, you may want to either exempt the animation or remove the control rig. That way it doesn't look so clunky of our character kind of doing a run up the wall. So that's all that really needs to be said for animations. Now, we have to work on our move event quite a bit because even though we move up, our movement is incorporating the entire vector. Since our up vector is 0, 0, 1, when we try to approach this from the side, our character is immediately going to try to move towards 0, 0, which is going to spin us around to face the same side. So we need to take our actor's forward vector, and we need to add it to the up vector. Now when we approach a wall from its side, our character is going to continue just facing the wall. So I'm going to increase the duration to 1 second, and then I'm going to take this wall and I'm going to just shrink it down. So our character is now going to run over the wall. Now we want to be able to stop our actor, so then when we reach the top of the wall, we end our wall run. So after our add movement input, we can drag over and we can get another line trace. Actually, it would be better if we just copied the first line trace because it's going to be exactly the same thing. So we put a branch, and the idea is that if we miss this, then we're at the height of the wall and we no longer need to be running anymore. So we can call stop wall run when our trace comes up false. And the reason why it's doing that is because we're calling stop wall run after 1 second, and if we end it prematurely, it's going to call it again. So now we need to get a branch after our timer delay, and we are going to just drag off here, and we're going to say is timer active by handle. And if it is, then we progress on to stopping our wall run. Otherwise, if we reach the apex before our timer ends, this branch will stop it from processing that twice. So we're going to go back to our map and we're going to raise the wall just a bit. We're going to see how high we can get without going over. Say change this to 0.8. Our character is continuing up at a linear rate, and it's also kind of slow getting up to speed. We want our character to have a quick run up and deteriorate over time. The best way we can do this is after we set this to our movement mode flying. We can get our character's movement, and we're going to set max acceleration. And I'm going to do the same thing I did with the other timer. Create event and select move from the dropdown. And we could set our max acceleration to be something insanely high, like 20,000. We just need to go back down to our character's movement and set that to be back to normal. If our max acceleration is only 1500. So now we should have a really quick run up. And then next, right before we do our second line trace here, after our movement speed, we're going to get a new variable. And this variable is going to be a float. And we could just call it time running. It's not going to be time in the strictest sense. But what it's going to be is our time running added to get world delta seconds. Then we are going to get a map ranged clamp. So if you haven't used this node before, we select a range between A and B, say 0 and 1 second. And if it's over ranged A, it outputs whatever we put in range A until it gets to range B. And then when it gets over range B, it starts sending the out range B. So if we wanted our max fly speed to be set, we'll take our character's movement, set max fly speed, and up until we get to 1 second, our outrange is going to be 600. Otherwise, if it's exceeding that, it's going to be 100. So now we accelerate and we have our character running up really fast. And then he slows down over time. And when we get off, we need to change our max fly speed back to default, which is 600. And we need to set our time running to just be 0. And so now you can fool around with these values of the delay. When you increase the delay, it's going to be the longer we're running on the wall before the timer runs out. You can increase the in range. Like I said, this was not going to be a definitive tracking of time. So if you want to see how long this actually takes, get a print, and we can print the in string. And if we run this for back to 0.8 seconds, so your character runs for nearly 1. So at 0.8, we get very close to 1. It's not going to go over 1, so it's not going to get to outrange B. But if we define 1 second as our delay time, you see we get up to 1.25. So that's just a measure if you want to fine tune that. Now, as a bit of a bonus, when we run up to the wall, we can add the ledge grab blueprint component from a few videos ago. So first thing we want to do is open up our animation blueprint. And in our event graph, what we want to do is, if you have the blueprint component, all you have to do is drag off of cast to your third person character, since that's the one that's going to be using the blueprint component. And we can just get BPC ledge grab. This is only if you have the blueprint component. Otherwise, you can just get the grabbed variable if you have it in your player character's blueprint. But we're going to have to convert this to a validated get and put that in between our character. And from ledge grabbed, we could just get grabbed. And we'll promote that to a variable. Next, in our main states, we're going to make a new state. This is exactly what we did in the last video of grabbed. So if we are jumping up, we do so when grabbed is true. If we are no longer grabbed, we're going to go into the fall loop. So grabbed, not bool. And then if we are on the fall loop and we were falling back onto a ledge to grab, you can select grabbed. And our grabbed is just going to be our wall idle, which I renamed as will idle because I can't spell, I swear. But what we're going to do is, to be able to get onto a grab from our locomotion state, we need to go from locomotion to grabbed and just simply add our grabbed here. So now when we run up to the top of our ledge, we can transition from our locomotion state, which is just walking and running, to grabbed. In our third person character, there's a few things we need to do. If we did our wall trace and we hit, we're going to grab in our BPC ledge grabbed, and we are going to start the grab timer. Then when we go to our moved actor, we are going to get a branch. We're going to drag in our ledge grab component, and we are going to get grabbed. So if we run up and we do a trace and we did not grab a ledge, we continue on with adding our movement. Otherwise, if we do grab a ledge, we want to stop running up the wall, so we can call stop wall run. And because our wall run state keeps us in flying, we want to change our movement flying only if we are grabbed. So we can just cut our falling out of the line here. And that's going to go at the very end. I'm going to get a branch. And just like we did with our branch off of moved, we'll add it here. If we are not grabbed by the time this timer stops, then we set our movement back to falling. I need to drag in the character's movement node again. And then I'm going to lower this wall by just a bit. We run up, our character immediately runs into the ledge grab. One quick fix we might want to incorporate though is when we start our timer for the trace rather than running on the wall, we can accomplish the same thing and prevent our character from starting a wall run when they're jumping or falling, so we can get our character's movement. And just call is falling. This way we can only initiate a wall run when we are on the ground. And that's pretty much all there is to a vertical wall run. A profound thank you to Winterberry Shark, Thatcher Moss, and Corpse Cats for their support on the Patreon. Link is in the description if you want to join as a free member and follow along with the channel's development. And as always, if you like the video, let me know by liking the video, and subscribe to let me know you want to see more content like this in the future. So with that, have a good day, and I hope you've been inspired.